Somewhere in the universe right now, there is a region of space where gravity is so intense that nothing, not light, not radiation, not information itself, can escape. Time slows down as you approach it. Space bends around it, and if you crossed its boundary, a point called the event horizon, you would be stretched into a thin strand of atoms in a process scientists actually call spaghettification. You would be dead long before you reach the center. But your atoms would keep falling. Forever. This is a black hole. And it is, without exaggeration, the most terrifying force in the known universe. But here is what most people don't realize. Black holes are not just cosmic vacuum cleaners sitting quietly in space. They are engines of creation and destruction so powerful that they shape the structure of entire galaxies. They bend time. They warp light. And in 2026, scientists discovered things about them that challenge everything we thought we knew about the universe. This is what they found. To understand how terrifying black holes really are, you need to understand how they are born. And the birth of a black hole is one of the most violent events in the cosmos. It starts with a star, but not just any star. A massive star, at least 20 to 25 times the mass of our Sun. For millions of years, this star burns through its nuclear fuel, fusing hydrogen into helium, helium into carbon, carbon into oxygen, all the way up to iron. Each layer of fusion holds the star up against the crushing force of its own gravity. It is a delicate balance, energy pushing out, gravity pulling in. But iron is the end of the line. Iron cannot be fused to release energy. When the core fills with iron, the outward pressure stops. And in less than a second, literally less than 1 second, the core collapses. The outer layers of the star come crashing inward at speeds up to 70,000 kilometers per second. The result is a supernova, an explosion so bright it can outshine an entire galaxy of 100 billion stars. But in the center of that explosion, something even more extraordinary happens. The core keeps collapsing. It compresses past the point of a neutron star, past the density of an atomic nucleus, past every known limit of physics. It collapses into a single point of infinite density called a singularity. And the space around that singularity becomes a black hole. From that moment on, nothing that crosses the event horizon will ever come back. Not even light. The black hole is invisible, a shadow in space, detectable only by the destruction it causes around it. Now let's talk about what black holes actually do. Because this is where it gets truly terrifying. When matter falls toward a black hole, gas, dust, or even a star, it doesn't just drop straight in. It spirals inward, forming a disk of superheated material called an accretion disk. This disk can reach temperatures of millions of degrees. It glows so brightly that it can outshine the entire galaxy around it. Some of the most luminous objects in the universe, quasars, are powered by supermassive black holes devouring matter at their centers. But the accretion disk is not the scariest part. The scariest part is what happens at the poles. As matter spirals in, some of it gets redirected by the black hole's magnetic field and launched outward in two colossal jets of energy, beams of plasma traveling at nearly the speed of light, extending for thousands or even millions of light years. These jets carry more energy than anything else in the universe. They can sterilize entire solar systems. They can strip galaxies of their gas, preventing new stars from ever forming. They are, in the most literal sense, weapons of galactic destruction. In February 2026, scientists announced the discovery of a black hole nicknamed Jetty McJetface. Its official name is AT2018HYZ. In 2018, this black hole shredded a star that wandered too close. That event alone was dramatic enough. But what happened next stunned the scientific community. The black hole didn't just consume the star and go quiet. It turned the remains into a jet of energy that has been growing stronger for 6 consecutive years. By 2026, the energy output was 50 times brighter than it was in 2019. Scientists estimate this jet is at least 100 trillion times more powerful than the Death Star from Star Wars. And the energy is still growing. Astrophysicist Yvette Sendes from the University of Oregon, who discovered the event, said, "This is really unusual. I'd be hard-pressed to think of anything rising like this over such a long period of time. Nobody knows when, or if, it will stop." And that was not the only black hole discovery in 2026. In April, Astronomers announced that a supermassive black hole at the center of a distant galaxy called J1007 plus 3540 had suddenly woken up after being dormant for approximately 100 million years. For 100 million years, this black hole sat quietly at the center of its galaxy, doing nothing. Then, without warning, it erupted, launching powerful jets that scientists compared to a cosmic volcano. The jets were so massive they could reshape the entire galaxy around them, pushing gas clouds, disrupting star formation, and fundamentally altering the structure of the galaxy. Think about that, a force that sleeps for 100 million years and then wakes up and reshapes everything around it. This is not science fiction. This happened, this year. Now let's go even deeper. Because the black holes we've been talking about, stellar mass black holes and supermassive black holes, are terrifying enough. But there is something even more extreme. In the early universe, just a few 100 million years after the Big Bang, something impossible seemed to happen. Supermassive black holes appeared, billions of times the mass of our Sun, far too quickly. There simply wasn't enough time for them to grow that large through normal processes. Stars hadn't been around long enough. Galaxies hadn't fully formed yet. And yet these monsters were already there, shining as quasars, devouring matter at rates that break the theoretical limits of physics. In January 2026, researchers using the Subaru telescope discovered a quasar at a distance corresponding to when the universe was only about 2 billion years old. The black hole at its center was growing at a rate that shouldn't be possible according to standard models. It was accreting matter so fast that it exceeded the Eddington limit, the theoretical maximum rate at which a black hole can consume material before radiation pressure pushes the infalling matter away. And yet, it was doing it anyway, while simultaneously producing powerful X-ray emissions and radio jets. According to existing theories, all three of those things should not be happening at the same time. But there it was. This means one of two things. Either our understanding of how black holes grow is fundamentally wrong, or something happened in the early universe that we haven't discovered yet, some mechanism, some process, some event that allowed these monsters to form almost instantly. But perhaps the most mind-bending thing about black holes is what they do to time. Einstein's theory of general relativity predicts that gravity warps not just space, but time itself. The stronger the gravity, the slower time passes. Near a black hole, this effect becomes extreme. If you were orbiting just outside the event horizon of a supermassive black hole, time would pass normally for you. You would feel fine, but if you looked back at the rest of the universe, you would see it fast-forwarding. Stars would be born and die in what felt like minutes. Galaxies would collide. Billions of years would pass in the universe while only hours or days passed for you. You would essentially be traveling into the future. And at the event horizon itself, time, from the perspective of a distant observer, stops completely. An object falling into a black hole would appear to freeze at the edge, growing dimmer and redder, until it faded from view entirely. It would never appear to cross the boundary. From the falling object's perspective, however, it would cross the event horizon in a finite amount of time and continue falling toward the singularity. Two realities, existing simultaneously. Both equally valid. This is not a thought experiment. This is what the mathematics of general relativity predicts. And every observation we have made so far confirms it. And then there is the question that keeps physicists awake at night. What happens at the singularity? General relativity says the singularity is a point of infinite density, infinite curvature, infinite gravity. But infinite, in physics, usually means, we don't know. It means our equations break down. It means we've reached the edge of human understanding. Quantum mechanics, the other pillar of modern physics, says that singularities shouldn't exist. That something must prevent matter from collapsing to a true point. But nobody knows what that something is. Solving this puzzle would require unifying general relativity and quantum mechanics, a problem that has defeated every physicist who has ever attempted it, including Einstein himself. In February 2026, physicists proposed a radical new idea. They suggested that a highly energetic neutrino detected in 2023 might have been produced by a primordial black hole. A tiny black hole formed in the first moments after the Big Bang, that exploded through a process called Hawking radiation. If confirmed, this would be the first observational evidence that black holes can evaporate and die, a prediction made by Stephen Hawking in 1974 that has never been proven. It would also suggest that primordial black holes could account for dark matter, the invisible substance that makes up 27% of the universe but has never been directly detected. One observation, one neutrino, and it could rewrite our understanding of black holes, dark matter, and the foundations of physics itself. Here is the truth about black holes. They are not just objects in space. They are boundaries, boundaries of our knowledge, boundaries of our physics, boundaries of reality itself. They are places where the rules we rely on to understand the universe simply stop working. And every time we think we understand them, they surprise us. They create galaxies and destroy them. They bend time and swallow light. They sleep for 100 million years and wake up without warning. They shoot jets of energy 100 trillion times more powerful than anything humans have ever imagined. And somewhere at their center lies something we cannot see, cannot measure, and cannot explain. The universe built the most powerful force in existence, and then hid it behind a curtain of absolute darkness. This has been the Odd Vault. If this unlocked something in your mind, subscribe, because we open a new vault every week. What they didn't tell you, we will.